In this video, we begin an introduction of coding structures in Java, which can check various conditions and make decisions to run alternative paths of execution. In other words, our program can have different ways to control the flow of its own execution. So at first, we introduce a set of relational operators which allow to construct conditions, also known as Boolean expressions, and the Boolean expressions return the values true or false. Just to give you an example, this is like a template code here, so this is not a real code, just a demo. So I can have a condition which we will soon construct using these operators, and I can have an if statement which will check this condition, and if the condition is true, so the outcome is true, these statements will execute. These opening and closing braces right here are also known as if block. So this is the block of statements that belongs to this if statement. Otherwise, if condition is not true, the statements below if will just continue to execute. So these statements will never execute, including situations such as if you declare a variable right here, integer x equals 1, 2, 3. This variable, if the condition is false, this variable will never be created. So this variable will never exist. So that's really truly optional statements to execute. Okay, so let's try a real example, not just this pseudocode. So let's say that we have some sort of a number, and we want to check whether the number is greater than 0. So we're using this greater than operator example right here. And of course, let's declare this value integer number equals 5. Doesn't matter, just the demonstration. So the statements to execute, we can run a simple system output print line and say that number is positive. And to give ourselves some kind of a reference below this if statement, we can also add something that says exiting by. Okay, so we're just exiting the program. So let's give this a try. Just save everything, just a quick run, and it says the number is positive, exiting. And if we change the number to say -5, the result is just exiting by. So this has never been run. I would just simply like jump from the condition which was false, so the number is not greater than 0, it's a negative number, so we just print this. Now we can also check if the number is less than 0, and then we can print the number is negative. Okay, so we can try this and run it, and this time we print the number is negative. So these are examples of these conditions, and of course we can also add a condition where we check for 0. Okay, so let's try that. The third example of if statement with a number compared to a 0. Double equal sign compares for equality on the left hand side and the right hand side, and if those things are equal, it will print number is 0. Okay, So we have these examples. So you see that as soon as we begin to add conditions and make decisions based on these conditions, the logic of the program keeps getting a little bit more complicated. You have more code to look at. So some examples of conditional expressions, and here these are not complete statements. So these statements do not have semicolon. They're not statements. They're just examples of expressions which can be used simply as conditions that we can give our if statements and other places where conditions can be used. So checks for equality, inequality, exclamation equals is checking whether the values are not equal to each other. So it will be, if subtotal is not 0, it will be true because it does not equal to 0. Greater, less, greater, equal, less equal. So these are all standard types of conditional operators and the expressions that using them. So if-else statement, again, let's just go to a first version that we're using here. We're just using plain if statement with a condition. We do it 3 times with 3 examples of an if statement, and the program seems to be working fine. I'm sure that it'll print number 0 if we change this value to 0. But normally you should begin to notice that some of the conditions are mutually exclusive. For instance, if the number is greater than 0, it cannot be less than 0 or equal to 0. We've already eliminated all possible choices. So if that is the case, it's very advisable to add an else clause over here and connect our statements like this. I'll explain to you in a second what has changed here. I'll try to format it to make it as readable as possible. Okay, so what we have is an initial condition which checks whether the number is positive or not. If this condition is true, okay, I'll use a little bit of markup right here. Right, so if this condition is true, this block of statements executes, and everything is fine, is going to print that the number is positive. Because of this condition, outcome already was true. In fact, let me change this to make it look like true. I will change it to +5 like this. Okay, so we start with +5, and let me run it so you can see that it just prints this. And I want to explain to you how this works. So back to marking here. Condition that we start checking, of course, is true because we print this. So this executes. And when we add an else clause to an if statement, so else clause, this else belongs to this if statement, because right here, this is the block that begins right here and ends right here, which formulates the block of this if statement. Right, so this all together right here, this is our if statement, like this. And this else belongs to this if. So this else always attached to the outcome of this condition. If this condition is true, the else block does not execute. Now, what follows this else block, let me just reset this. Right, so what follows this else block right here, starting from here, that belongs to this else, is this next if statement, which of course has its own block, which has the condition, then the block. It's all part of the if statement, and it ends right here. And then you see there's another else. So this else is attached to this if, so therefore it's part of the same part of the same logical structure. Now, we also have another if statement, which of course is attached to this else. So this if statement follows this else. So therefore, it still continues to use it as one structure. And of course, this if statement finishes right here. In other words, starting with this else if, this entire section of the code from here all the way to down here, all of this, is basically belongs to this else. It's attached through a series of if-elses like this to this else. And therefore, this condition, the initial condition, if it's true, makes sure that none of this is ever evaluated. If it's true, this doesn't exist, doesn't execute. Okay. Now, if we change it back to -5, so this condition becomes false, right? So these statements right here inside the if block do not execute because condition is false. However, what happens is that we now else is going to be given a chance to execute, and it allows this if statement that follows it to check this condition, which is different condition. So it happens to be that this condition is now true. So of course we are expecting to print this on the screen, right? So this will be printed because this condition now is true. This was false, now this is true. So this will be printed. What happens next, that I told you that the else that follows this if block from here to here, right? So this else is attached to this if statement. It will not execute, right? It will not execute because this condition was already true, and else provides an alternative to a true condition. And the same logic follows that this if is attached to this else, and therefore none of this will execute, right? So this will be ignored because this condition was true. So here, this was ignored because the first condition was false. Then we found a way to check this condition. So this condition happened to be true. We execute this block, and this is now also ignored. And finally, when this becomes a 0 case to examine, once again, this condition is false. So this is skipped, right? So we skip this. We say else, let's try something else. So let's try an alternative. So we have another if statement now connected to this else statement, not standalone, but follows the else. And so it checks this condition, which is also false because the number is 0. So this causes this block of statements to be ignored. So they never execute. Finally, we have the third else, which now continues to execute because this condition was still false. Remember, this else is connected to this if statement. This else is connected to this statement. And this if is connected to this else, so this else lets this to continue. So we check this condition, of course it's true, and trivially this gets printed and we're all done. So we just fall through the code, right? So to summarize, this if-else ladder, this structure, I'll show you another way to format it in a few seconds. But this structure, if, else, if, like this, also known as if-else ladder, allows to check the conditions which are treated as mutually exclusive choices, right? So we say that if this condition is true, there is no reason to do any of this. All other conditions are simply ignored and no longer need to be checked. If that's not true, so we have to continue finding the true condition. So then we make the second choice and we say, okay, let's try to find out if this is true, and then this will be executed accordingly. And so we can chain up plenty of these conditions, and they can grow in number, and they're all, because of this nature of if-else connections, this creates a set of mutually exclusive choices. So if you have this situation like this, then if else is the right choice to start making your decision and alternating these paths through different parts of the code.